Hello everyone, my name is Nabila and today my group and I would like to talk about the analysis of beam in our truss footbridge. First of all, the footbridge is simply supported and it has a uniformly distributed load acting on its beam. The objective of this project is to identify and idealize the real structure by using Macaulay's method and moment area method for deflection of the beam. And secondly, it is to analyze the stress and deflection and validate it by using modern analysis tools.
Hello, my name is Jason Aaron Anaholis. I'm going to present to you about theoretical background, the beam analysis, and the geolot of the bridge. First of all, we go for Macaulay's method. The technique used in structural analysis to determine the deflection of the beams. It uses a single equation for bending moment for the full length of the beam. Slope can be obtained by integrating bending moment, and deflection can be obtained by integrating of slope equation. Next, we go for the moment error method. It is a technique for measuring beam structure deflection that focuses on the shape of the bending moment diagram. For the calculation of the deflection, two theorems known as the moment area theorems. One theorem is used to determine the angle between any two tangents on the elastic curve, and the other theorem is used for measuring the vertical deviation at a second point, which a point on the elastic curve and a line tangent uh, to the elastic curve. Okay, next is beam analysis. We have calculated the beam and we found out that it is the same for reaction at A and reaction at B because it is a simply supported beam which is 1148.4 kilonewton. And for the bending moment diagram, the maximum bending we have is 4306.5 kilonewton meter. And then for the axial load of the bridge, the diameter of the steel we use is 12 millimeter. The length is 15 meter. We assume that the E of the steel is 200 gigapascal, and for the E of the cone is 30 gigapascal. After we have calculated everything, the stress of the concrete is 46.905 megapascal. That's all for me. Thank you.
So, good evening, everyone. I'm Adrian Tosantarawe. So, today I'll be talking about the software calculation using Start Pro for our analysis of beam for the bridge. So, basically, we are doing a truss bridge, which is Howie truss. This is the picture of the bridge, and this is the picture of model that I'm doing using Start Pro. So today I'll be talking about the deflection, the shear stress in X and Y direction, the bending moment. So what we gain from the software calculation for the deflection, firstly is negative 930.766 millimeter, while in the manual calculation we gain negative 0.7477 millimeter, where it has a huge gap of difference. Maybe it's because of the assumption that we calculate through the manual, or maybe in the software it calculate the bracing and the reinforcement in the concrete slab, where in the manual calculation we didn't include, we ignored the reinforcement. So the type of beam that I'm using is the British Standard UC 203 times 203 times 127, where it has a mass of 127.5 kilogram per meter, depth of 241.4 millimeter, while the width is 213.9 millimeter. Next is the web thickness is 18.1 millimeter, and the flange thickness is 30.1 millimeter. So what I can say is make a different calculation in the software. So next is the shear stress in X direction is equal to 0. while the Fy, what we gain in the software, is the same as the manual calculation, which is 1148.4. Next is the bending moment. All the maximum bending and deflection is occurred at 7.5 millimeter, half of the beam length, which is 15. So I can say that for the bending moment, what we gain is 1743 throughout the software, but in the manual we gain around 4000 plus. So it has also a huge difference due to assumption and maybe different calculations. So that's all from me. Thank you.
To explain about the calculation of deflection by using Macaulay's method for our bridge. First, we cut at the end of the section to find the moment equation, which is equal to 1148.4x minus 76.56x squared. And then we find the slope and the deflection equation. For slope equation is equal to 574.2x squared minus 25.52x cubed plus C1. The deflection equation is equal to 191.4x cubed minus 6.3x the power of 4 plus C1x plus C2. And then we apply boundary condition to find the C1 and C2. For slope equation, the boundary condition is x is equal to 7.5 and the theta is equal to 0. From there, we can find that C1 is equal to 21532.5. And then boundary condition for deflection equation is x equal to 0 and v is equal to 0. From there, we can find that C2 is equal to 0. And then we put back into the equation and find the deflection at the midpoint, which is the maximum deflection. From there, we can find the maximum deflection for our bridge is negative 7.477 times 10 to the power of negative 4 meter. Thank you.
Greetings to all the lecturers. My name is Muhammad Amin Ashraf bin Ramzan, and I will present about the discussion for our poster. So in this project, there are three methods used to calculate the deflection of the beam, which are by Macaulay's method, moment area method, and by using a software. So based on the result obtained, the result of the deflection from Macaulay's method and moment area method are the same. So in Macaulay's method, it has a negative sign indicating that the beam is bending downwards. However, the results of deflection between manual calculation from both Macaulay's method and moment area method are different with the result from software calculation. This may be due to certain assumptions made in manual calculation and some add-on values from the software. As for the shear stress, the value of shear stress between manual calculation and software is less than 1%, so this might be affected by different number of decimal places. In conclusion, the problem analysis for real structure have been identified by calculating the deflection of the beam. So the deflection of beam obtained by Macaulay's method and moment area method is 0.7477 millimeter, and the deflection of beam obtained in the software is negative 930.766 millimeter. While for the shear stress, the value obtained is 1148.4 kilonewton in manual calculation and 1148 kilonewton in software.